Alright, so now we have angle 1 and angle 2 are complementary. So we're going to pause here and say, yay, 90 degrees. I know what complementary means. Alright, and then it's telling us that the measure of angle 1 is 3x, the measure of angle 2 is 12x, saying find the measure of each angle. Alright, so all I'm going to do is apply the angle addition postulate. I'm going to say, well, 3x plus 12x equals 90 degrees. Alright. So this one we really don't need to draw a picture. We have to just be able to say complementary is 90 and know that we have to add those. Then we just solve for x, and x equals 6. And then a huge life skill to have, it's a lot harder than you think, it's find the measure of each angle. So bloop, measure of angle 1 equals 3 times 6, or 18 degrees. Measure of angle 2 equals 12 times 6, also known as 72 degrees. Alright, so complementary 90. This one's telling us it's supplementary, so we automatically know, boom, 180. It's just telling us to solve for x. It gave us that, it gave us that. All we got to do is say, well, 2x plus 3 plus x minus 6 equals 180. Alright. Then we get 3x minus 3 equals 180. So how do I undo subtraction, addition? 3x equals 183. X equals 61. Alright, so supplementary 180. This happened to be adjacent. Little fun fact, this was also a linear pair. And we have a linear pair problem down here. So again, with these problems, you don't really have to draw pictures. It's more of just identifying the terms and what they mean. Linear pairs are supplementary, which is just a fancy way of saying 180. So this one right here is essentially the same as the picture above. Alright? And then we got the measure of angle 1, the measure of angle 2. We got to find the value of x. So 21x plus 6 minus 2x plus 22 equals 180. Alright, and again, I think setting up the equations, the hard part, solving it, different story. That's algebra stuff. Just combining like terms on this left-hand side. Plus 28, and then just going to equal 180. So after I combine like terms, now I need to get x by itself, so I'm going to remove this 28. How do you undo addition? Subtraction. So I'm going to have 19x equals 152. And then I'm going to, how do I undo multiplication? Division. I'm going to have 152 divided by 19 is 8. Found the value of x, solved it. So we'll put 8 right here. And we'll make this 8 look cool. Little smiley face here, little smiley face here. It's a really happy 8. Look how happy that 8 is to exist. Hooray, 8. Find the value y in the figure below. So look, this doesn't even tell us anything, but again, we have to be really good at this. I'm not over-exaggerating. I'm not saying it's important just to say it's important. This is important. We have to immediately see this x and think these are vertical angles. Alright, not only do I have to recall that they're vertical angles, I have to recall that vertical angles are congruent. This is a huge property of math, alright, of geometry. It's going to be the first theorem that we prove. In the later unit, we're actually going to prove math to be true. The very first one we do is the vertical angle congruence theorem. We prove that any angle that, or any vertical angles that have existed in the past were congruent, that any vertical angles that currently exist are congruent, and that any vertical angles that will be drawn in the future will be congruent as well. Powerful stuff. Alright? The math is all around you. It's a powerful ally. Don't forget it. But anyways, you set up this equation, and then it's just a matter of solving for y. Alright, we're going to get 7y equals 91, or y equals 13, because I divided both sides by 7. Okay? And then we got some logic table right here, just kind of organizing all our thoughts. We're going to do that in the last video. Stay tuned.